MODO. Morsels.
In this morsel, I'm going to discuss measuring angles, and we'll make a cause for celebration. To define an angle, we will need 3 points, which describe 2 lines crossing at a shared point. The angle between these 2 lines is what we are interested in. In MODO, the sensible way to measure an angle is to use the aptly named Measure Angle Modifier. The positions of the 3 points are input as matrices, which is usually convenient as we can use the world position channel of an item for this purpose. The first position is the intersection point. Feed the remaining points into the other 2 and, hey presto, alakazam, we have an angle. Whilst the modifier is selected, you will see the angle in the 3D view. The output channel has the angle value for you to use however you wish. Presumably you wanted to know the angle for some reason. But that was far too easy. Let's don the hair shirt and do it the old-fashioned way. We're going to have to use some maths. Be not afraid. The angle theta between 2 vectors can be calculated using this formula. A dot B is the dot product, which is the sum of the products of corresponding components, and bar A bar is the magnitude or length of the vector. We can simplify our lives by first normalizing our vectors A and B. Then their magnitudes will become 1. So the angle formula reduces to theta equals inverse cosine of A hat B hat. So here it is in MODO. First, we need to convert our position matrices into XYZ positions using matrix vector. Remember to select the translation row. Next, we need to create the vectors by subtracting the intersection point. In my case, the common point is the origin, so I don't really need to do this, but at least we should try to be general. After this, we just follow the formula. First step, normalize. MODO has a vector normalize modifier for this very purpose. And then finally comes the dot product, and MODO has one of these too. The result is a scalar value in the x component of the result vector. To get the angle, we need to use arc cosine. But what is this? I can't find Acos or Arccos or Invcos or anything that looks anything like an inverse cosine. All is lost. Fortunately not. Arc cosine is hiding in plain sight. Look at this cosine modifier. Aha! There is an inverse button in there. So to get arc cos, we use the cosine modifier and check the invert button. Easy when you know. Of course, the same applies if you want to arc sine or arc tan. Plug that in and we have an angle. And, amazingly, it is the same angle as reported by the Measure Angle Modifier. Isn't maths great?
MODO. Morsels.